Now that we have covered week 2, let's go on and move on to some practice exercises. So obviously we've covered pulls on multiple sketches. Let's try that again. Let's recap first. As an example, if I draw multiple area sketch as so, just as a quick example, and I hit the pull tool, it highlights, or SpaceClaim highlights, all the enclosed areas of the model. Obviously, you can click while holding Control and select all of the enclosed areas to perform a pull at the same time. However, if you click several areas or not all of the areas, you can do a pull on multiple surfaces, right? Then if we pull these other surfaces, we can pull them in the opposite direction, sort of creating a more complicated shape or feature over here. We can pull it in the other direction as well, if that's what we wanted to do. Obviously, using Control Z as we described in the week 1 lectures to undo some of the features or moves or changes that we've made. You can make quite interesting geometry or quite complex geometry using this method. Again, as I've mentioned during week 1, it's always useful to practice all of these tools and features just to get used to them. The more you practice, the more confident you will be using these tools. Let's perform, or let's create a nice little square area. We can divide this grid in several different sections, so we can split it as such. Again, just a quick example that we'll do over here. Obviously, it is advisable to test, play around, try these tools for yourself. Think of some interesting features or geometry that you could do and try to recreate them using the tools that we have learned up to now. Obviously, we'd learn more tools as the weeks progress, but if we created a grid as such, as an example, plan that we have loads of features or loads of areas that we can select and pull on. And as you can see, within a matter of minutes, we've created some relatively interesting geometry over here. Multi-leveled structure. That's just one example of using the pull tool on a multiple area sketch. However, let's say that we're more interested in creating holes or negatively extruding or cutting geometry out. So let's start off with a normal rectangular prism over here, or a block or a box per se. Again, when you hit sketch, you are able to select a plane on which to sketch on. This can be any of the surfaces, right, of the geometry. You can even select it at the intersection of some of the geometry, right? Obviously, if you create some reference geometry and some additional planes onto your sketch, you could put planes and start sketching on different areas, even intermediate areas, sort of as a cross section of the model, if you so wished. Now, if we created a few holes over here, right? First off, we have to select some geometry or sketch some geometry for us to manipulate. Actually, you know what? I have an interesting idea, yeah, for a real-world application, right? If we do a couple of bounding boxes over here, as such, I'm just roughly drawing the geometry as I go along. Obviously, in your case, you might want to take more care of the dimensions and positioning of your sketches. But as I'm only doing an example just to demonstrate the point, doing it relatively quickly and fast. If we hit pull right now, you can select all of these boxes that we have drawn, not the main body, by holding Control and clicking. Then if we do a pull cut, you can see sort of what we obtained over here is similar to an ice cube tray, sort of something that you could design obviously a bit better with more accurate dimensioning of the parts and of the holes and more accurate placement of the holes to obtain the results that we wish. Obviously, if you wanted to continue editing this geometry or this model, you could select a different face if you so wished. One thing that I'd like to mention is whenever you click the middle mouse button to rotate your model, yeah, click and drag, the point where you actually click will be the center of rotation of your model. So if I click around this corner, it would select that corner. So I'm rotating the whole model around that specific corner. Whereas if I click the center, I'll rotate the model specifically around its center. And this is just some quick tips and tricks. Obviously, you can also use the axes to align your geometry to a specific location or specific direction. If we create some reference geometry as in over here and negatively extrude this all the way to the other end, that will create a whole cut through the model. And as you can see, now we have a multi-layer model. So these holes, they went all the way through here, and we created another hole that goes through the side of the model. Those holes interact with each other. As such, you can create some interesting models or geometry in this way as well. If you wanted to, as an example, let's create a sketch on this plane. Let's try to create a diagonal line over here. Let's see if we can create a plane on this line over here. Yeah, that we've just drawn. Actually, wait, I'm still in the line tool. Let's exit that line tool. Let's create a plane. try to create a plane along this line as a diagonal plane. You see now that I've created the reference geometry. It gives me something to snap onto and create the plane. Obviously, SpaceClaim tries to interpret what you're trying to do. It tries to predict what you're trying to do, so it saves you a lot of clicks. You don't have to fully define geometry or parameters in order to do such things, as long as you have some sort of reference geometry. So obviously, a plane would be defined by two sides as a minimum. Yeah. If you have two axes or two directions such as X and Y, that will create the plane on the XY plane. But considering we have this diagonal line, sort of SpaceClaim predicts that we'd like a plane along the line, and we can sort of create a plane along that direction. Once you create the plane, when you select sketch, you can select, if you exit the plane tool, once you select sketch, you can select the newly created plane as a sketch plane if you so desire. And then once that is selected as a sketch plane, right, this is another quick tip. Obviously, instead of fumbling around, rotating, moving about, if you actually just want to face the plane that you're sketching on, if you select this button over here, plane view, or quick key V for view, you would be directed perpendicular to the plane that you are viewing or to the plane that you are sketching on. And you can sort of, as an example, we're now sketching on this diagonal plane. If I sketch some geometry on there and I use the pull tool on this surface, you can get, you can get some edges or some geometry diagonally to the plane that you are sketching on. Obviously, if you didn't want to add geometry, if you wanted to actually remove geometry, as I've specified, you can click Cut to remove material. And now, as I drag this plane, it removes material instead of adding it, right? Obviously, the plane that I've added, I didn't add the line directly along the point or along the edge, so that's why I have some additional geometry around here. You can also, there's a tool over here next to add and cut, there is no merge. So pretty much what no merge implies, this is more so for assemblies, but however, if we discuss the context of assemblies, which are different parts, so if we think about it as a screw and nut, right? Let's work on this example. Right? If we just select all of these curves or all of this geometry and get rid of that, let's start a new sketch plane. If you remember in the previous example, we created sort of an example of a bolt just by creating some polygonal geometry. Then we started sketching on the top face of the hexagon that we extruded, creating a little circle on there for the bolt main surface. Pull that up, right? We have an example of a bolt over here, a simple bolt. Now, if we wanted to draw, let's say, a nut on here, or a mating nut as an assembly, if we created another polygon with a circle of the same diameter as our bolt head, and we click pull to sort of extrude the nut. If we click this surface and we extrude it downwards, sort of create a figure of a bolt going through a nut. However, if you look over here, this becomes one solid body, as you can see. But obviously a nut is generally separate from the bolt. They're not one piece. They move around, they interact with each other, but they're not, one solid body. You can create, you can click on no merge. And now when you extrude, this creates, if you look in your design tree, another solid body. So you have the nut solid body and the bolt solid body. So they're two separate entities, right? And if you wanted to, you can click on the nut, you can hit move, which we'll discuss later on, and you could move this nut up and down on the bolt to change its position. If we didn't do that, as an example, let's extrude it again without using the no merge tool. Now, if I clicked on and selected this body, it would select the whole body. So we wouldn't be able, if we use the move tool, to, let me click that again. If we use the move tool, we wouldn't be able to move that nut specifically because it's one whole solid body. By using the no merge, you can create an assembly of parts, several different bodies, and that gives you some more options when you're modeling or creating geometry. However, in the context of 3D printing, generally you wouldn't print whole assemblies, you'd print individual solid bodies or individual parts. So that's why we're only going to touch upon this topic. We're not going to go into too much depth or detail, but however, for other modeling applications, you might find this feature useful. When you create, or obviously you want some bodies to interact with each other, but you don't want to create an extrude or a hole that goes through your body. Yeah. So that's one example of how we can use the pull tool with the no merge feature. Obviously, we've discussed rounds and chamfers, or chamfers and fillets, however you might want to describe them. Obviously, that's done just by selecting an edge, right? Because you create a chamfer or a fillet on an edge rather than a whole body. So if you wanted, obviously, screws, nuts, and bolts, they're not generally, 100% straight or the same surface area at the tip. You have some leeway to help the bolt go in. You can add a fillet over there, or more so a chamfer. In this application, you can do it that way if you wanted to a certain point. Obviously, and that would help in a mechanical engineering perspective or from a design point of view. It would help you locate your bolt through assemblies or through pieces. Yeah, this is just some of the properties that you can edit, you can change, or how you can use the pull tool in a more complicated fashion. Obviously, we discussed previously the scale body tool in week 1 and the additional practice content. If we scaled this whole body across that, you can make a smaller bolt, you can make a larger bolt depending on what scale you want. Obviously, now these two pieces are clashing or interacting with each other. They're still two separate bodies, two separate entities. Obviously, we'll discuss the move tool in more details, but as you can see, you can edit, you can adapt, you can move several pieces together. Also, if you wanted to scale two bodies at the same time, as you notice, I'm going off of the structure tree because it's easier to select rather than triple clicking a body as we've discussed previously. You can also hold control and triple click the two separate bodies, but remember, if you don't hold control and you triple click, you will lose your previous selection. So you can triple click both bodies and using the pull tool, yeah, and using the scale body tool, you can actually scale whole assemblies as well. This is more so useful when you're working with several assemblies. Obviously, I keep mentioning the move tool, which we'll later discuss in more details, but you can use that to move different parts of an assembly around. If you wanted to actually locate them specifically to a certain area, or you're not happy with the positioning relative to the other components that you have in your assembly, that's something that's useful, in that application. You can also, if we move this bolt out, let's say we're not happy with this hole. Obviously, we've discussed the fill tool, right? Where you just select something and it sort of fills the hole or fills the feature property. Again, it depends, right? So over here, what I just did is, let's say you're not happy with this surface. If you click fill, it tries to fill in the area or remove the feature in a logical way, or SpaceClaim tries to predict what you're doing. So obviously, how would you fill this area? You'd connect the left hand and the right hand edges, or you connect the top and the bottom edges, sort of a way. It tries to do it in the least obstructive way, right? So if you selected 3 edges of your nut over here as such, and you click the fill tool, you end up with a triangle, right? If you selected all of the edges, let's see what the fill tool will do now. Obviously, it says failed to remove surfaces. Now, why does this happen? Well, try to think of it this way. Try to think of it from a programming perspective or from a program perspective. Obviously, the fill tool tries to predict or tries to remove geometry in a geometric way. If you select all of the faces of a body, the program, so SpaceClaim, cannot geometrically or mathematically complete that action. It's a mathematical abnormality for it. So sometimes you might end up with these issues, especially if you get adjacent faces. It cannot exactly predict what you're trying to do. So it's not a solve all. As you can see, it only works in certain situations or certain applications. If you try to fill just any random surface, it won't do that. Generally, what it tries to do, it tries to remove features that you've done. So on our bolt over here, I've selected the chamfer that we've done to sort of create this leading edge. So if I selected the fill tool, it would predict that we don't want this chamfer anymore. We want to fill that space that we've cut out. If I hit the fill tool, it would sort of revert it to a previous property. So as an example, let's say, okay, you've created this assembly, you've created a nut and a bolt for a specific application, for a friend or for an end customer, or for a business proposition. Just as an example, you've sent them this CAD data and they're like, oh, okay, that's pretty good, but are you able to remove this chamfer, as we do not need the leading edge on this bolt. We want it to be flat. You say, I have a problem now. I can't just click Control Z because it will take me to many different areas, and it's not actually, it won't help you. You might not be able to do that, especially if you save the data and import it. SpaceClaim will lose track. It will not save all of the actions or operations that you've made, so you'll not be able to Control Z. It's similar to a lot of Microsoft Office applications. So if you're editing a Word document, you save it, you leave it, you come back to it, and you're like, previous version that I've done was better. I'd like to undo some of the changes that I've done. You can't just hit Control Z to go back to a previous state, because that's stored just in a temporary sort of field in the RAM of the computer. So that memory of those actions is lost when you load the file back in after you save it. So one way to get around this is to save several iterations, so several versions of the files after you do loads of design changes, so you can go back to a previous version. Or simply, this is where the fill tool comes in. Let's say you don't want this feature that you've created, can't really get rid of it unless you want to do the pull tool, cut this edge or extrude this surface area all the way up to this point. But just by clicking the surface that you want to remove, clicking the fill tool, you can get rid of some of the features that way, right? Maybe if we click the fill tool over here, sometimes maybe if we did an extruded cut from here all the way down, it might have been able to fill it back up, but obviously it's very limited in its application because it's a predictive tool. It tries to figure out what you're doing just based on some geometrical properties or previous actions that you've done. So it's not a sort-all, it's not a magic tool that can solve all of your problems, but it can be useful, as we've discussed in week 1 with some of the other sketch tools. In limited applications, it can be useful. Obviously, the more you practice with the tool, the more you understand it, the more you understand what situations it can be useful in. Yeah, you can get better at designing parts. And yeah, even if, as an example, you received this design from someone else and you're asked to make a few changes to it. So let's say you have this bolt, and let's say they say, oh, well, we want to be able to secure this bolt from the outside with a wrench, but we also want to secure this bolt from the top with an Allen key. How would you do that? So obviously you can select the top face or the top surface, you can go down, or say as an example, an even better example than what I just mentioned, you have a bolt, and obviously not everyone has a wrench at hand. Obviously a more common tool that people have is a screwdriver. Well, you could easily, I say easily, but if you have some good design knowledge, you can create over here, obviously using the rectangular tool and the trim entities tool, you can create a screw head on top of the bolt, right? So what does this mean? This means that what we've created just now is a fixing or a bolt that can be secured or assembled using two methods or two tools. Yeah, you can use a wrench on the outside surface. You can even use a screwdriver on the top surface. You can use a flat head screwdriver or a Phillips head or crosshead screwdriver on top of this as well, right? That gives a supplier or a manufacturer more flexibility in the assembly method that they choose, just as an example, right? And then they say, okay, but this is quite pointy, we don't like this excess area. You can just select it. As we mentioned previously, you can use the fill tool. And this is just some examples of how these simple tools that we've learned in week 1 and week 2 can give you such a wide range of design opportunities, yeah, if you use them in a clever way, right? Obviously, as an example, a paper and pen, they're very simple tools, but you can create wonderful works with them. You can write a novel, you can write a biography, you can sketch a painting with the pen and the paper, you can write important information, you can do so many things with simple tools. And it's the same concept when you're 3D modeling in SpaceClaim, right? Your imagination is the only limit in this situation, right? So what else can we do? What other features do we have over here? We also have, let's say, let's do a bit of undo over here. Let's go back to this example, right? Let's say we created, sorry, I was stuck on the move tool. Let's say we've created this nut and bolt assembly, right? But as an example, let's say that you actually want to have a bolt that has two areas or two surface areas that we can use, right? As per the previous example where we added a screwdriver inlet or a screwdriver securing location onto the bolt head, we can add several different surface areas to the bolt. However, in this application, we have two solid bodies over here that we're working with, right? So when you're 3D printing, right, you'll have a bit of an issue because when you export this model, you'll export it as two entities. You'll have to print them separately. You might have to glue them together. You might have to assemble them. It would be much easier if we had both of these bodies as one solid body, as one body instead of two separate ones. Now, how can we do that? Obviously, we can go back to the drawing board. We can do, a few more sketches, right? But there is a tool, 3D modeling tool that we can use. It's called the combine tool, right? Again, I'm only specifying this in the surplus or practice information to the course, as it's only used in a limited number of applications. It's not that common. But just by giving you an overview, if you encounter such a specific application, it might be useful to know it. It might be useful to use it. If we hit it, if we click it, you can see that the body, the two solids have become one now, right? See, now it's just one solid body. And if we exit, right, now it's one solid body that we have. However, let's say that we actually start with one solid body. So let's go back a few iterations. Let's say that we had, sorry, please excuse me. Let's say that we had, all right, let's combine these two. Let's say that we designed this body in the first instance, right? Let's say we didn't split the model. Let's say we made a mistake and we didn't use the no merge application of the pull tool, and we ended up with the nut already attached to the bolt as one solid body. And like, we have to go back to the design phase. We might have to undo. It's a bigger issue if we've already saved the model and we import it. You might panic and you might think that you've lost a lot of design hours and design work and you might need to start from scratch. Well, the combine tool that we just discussed doesn't only apply for combining assemblies. You can also separate the assemblies if you wanted to. So over here, you can select what area you want to cut, right? So you can click on the object that you want to split, and you can click on a surface, right? If it lets me do this, right? Okay, so What I'm trying to do now is I'm trying to select this surface for the body to actually cut, but it's just not cooperating with me.